Okay, this one we're going to start section 13.4. Here is the big deal, no worksheet. I'm not actually going to do worksheet problems. And the reason being is, let me give you some background here. The type of, there's all kinds of ways to factor trinomials. But one is called guess and check. And mathematicians, myself in particular, don't like this word, but sometimes it's unavoidable. And that is equivalent to our method, this method here. This is just an easy way to guess and check. The other is called the A-B method. Or sometimes known as factor by grouping. And I think just teaching you one method of factorization is fine. So what I've done for your homework for section 13.4, it's not the A-B method, it's the AC method, sorry, the AC method. What 13.4 actually does is really teaches you the AC method, which uses factoring by grouping. So what I've done is, instead, we're going to look at problems where we factor polynomials of the form ax squared plus bx plus c. Notice the difference here? Well, you will when I write this. A is not equal to 0. So we're still going to use this same method. And then after that, we're going to factor by grouping by looking at groups of 4 terms like we've done earlier. And the homework has been changed, has been designed to reflect what we're doing here, not on the worksheet. So you need to ignore the worksheet, don't do it, and we're just going to do the problems that I've got here. So the first one we're going to do is, here we go. It's a polynomial whose leading coefficient is not 1. See that 11 right there and that 3 right there? And the GCF of all of its terms is equal to 1. But as it turns out, we can still use our method just as before without any changes. It just requires a little bit more of the guessing. So here we go. We write our table. Again, we write our first term, which is 3x squared. And then we write the constant term, and then we write the middle term. Now, as it turns out, and this is literally what converted me to this method, since the coefficient of our degree 2 term is prime, there's only one way I can write the first row. One factor has to be 3x, and the other is x. Now I have to deal with 6, but notice the difference here. There's more to these. There's more guessing and checking, as you're going to see. Suppose I put 2 here and 3 there. So once I've discovered that the only factorization into 2 terms, which both have variables in each term, is 3x and x, and we never put negatives in the first row. Never negatives. In the first row. They're always positive. Now let's just do 2 times 3. So 3x times 2 is 6x. And x times 3 is 3x. Well, 6x plus 3x is not equal to 11x. But I've got to change the order, because what's in the first row in both of those boxes are different terms. Changing the order will be different. So let's do 3 times 2. Instead of 2 and 3, 3 times 2. So 3x times 3 is 9x. X times 2 is 2x. Now I have it. 9x plus 2x is equal to 11x. 3 times 2 is equal to 6. And 3x times x is equal to 3x squared. And everything from here on out proceeds exactly as before. We read our factorization off exactly the same as before. The only thing is we may have to switch the order of our factors in row 2. That's one thing. And the top row, there may be more than one different way to write out the factorization. That will always be the case when the leading term is not prime. But many times the leading term is prime. So that's what makes this really, really nice. So this is equal to 3x plus 2, 3x plus 2, and then x plus 3. Okay, let's do another one. We've got several examples of these, and then we're going to do basically what I'm reviewing right now for you is exactly what's on the homework, and it will be pretty much what's on the exam too. There won't be anything in section 13.4 that we do not cover here in this particular lecture. So our next one is 2x squared plus 13x, plus 15. And again, always when the leading term is not 1, check the GCF of all of your terms. So the GCF of 2x squared and 13x and 15 is always just equal to the GCF of the integers, and it's just equal to 1. So I can't know factoring out the GCF that's going to help me. So I'll make my table. And thankfully, my leading term, since the leading term is the 2x squared, the leading coefficient is 2, and that's prime. So I'm just going to put 2x in x, and that's it. I can just leave it right there. I'm done with the first row. And whenever the leading term is prime, it doesn't matter if you put x or 2x, it doesn't matter. Once you got it there, just leave it and never make any of those factors negative. Now I want to get a 15 as my constant term and 13x here. So 15 has a lot of factors. So let's try the obvious one. And this is, again, where the work comes in. This is the guessing and the checking. Let's try 3 times 5. Well, 2x times 3 is 6x. And 5 times x is 5x. Well, 6x plus 5x is 11x, and that's not what we want. We want 13x. So let's try 5 and 3. Well, 2x times 5 is 10x. And 3 times x is 3x. Okay, not so bad. 10x plus 3x is 13x. 5 times 3 is 15. 2x times x is 2x squared. So I have my factorization. And I'm good to go. So my factorization is 2x plus 3. And these can be in any order, x plus 5. So not too bad when the leading leading coefficient on the degree 2 polynomial is not 1. So here's going to be a difference. We have 12. See, that's not prime. X squared plus 13x plus 15. This is so much easier than any of the other methods in my view, even when the leading coefficient of the degree 2 term is not prime. So notice there's a lot of different ways to factor 12x squared. I could do 12x and x. I could do 6x and 2x. I could do 3x and 4x. Choose one of them and stay. So I'm going to choose, well, we may have to go, you might want to put over here the pairs, just to remind you. What's going on? It's not wanting to write. Now they're writing. Still not writing. So we might want to put over here, just as a reminder, we have 3x and 4x. There's no reason to put them like this, but I am. 6x and 2x and 12x and x. And that's pretty much it. So just choose one of these, and it doesn't matter the order. So I'm going to choose 3x and 4x. I have no idea. Like this is the guess and check aspect of it. And so there's a guess and check there's a guess in the first row, and there will be a guess in the last row. Let's finish filling in my table over here. 15 goes here, and 13x goes here. So I'm going to try 3x and 4x, and it doesn't make any difference. And again, these are never negatives, and just choose an order, because any order changes can happen in the second row. And for 15, I'm going to do 5 times 3. So 5 times 3x is 15x. Ooh, that's too much. So I already know that 15x plus anything else is not going to be 3x. So let's erase. Well, if I change from 5 to 3, 3 to 5, well, if I put a 5 here, instead of speaking, let me just show you. If I put a 3 here and a 5 here, 4x times 5 is going to give me 20x, and 20x plus 9x is not going to work either. So this would be 9x here, and this would be 20x, and that's certainly not 13x. Well, what else can I choose for factors of 15? 15 is 3 times 5 and 15 times 1. And that's it. So it looks to me like if I use 15 and 1, if I put 15 in either of these two, then I'm going to be adding 15 times 3x. And that's always going to be greater than 13x. So it looks like I need to mess around with these. So this one did not work. I'm getting rid of it. Don't want to see it. Didn't work. Let's try 6x and 2x. Well, 15, 3x, that's not going to work. And then the other is 5. That's not going to work. Because 6x times 3 is 18x. It's already greater than 13x. So that's not going to work. And if I change and I go 5 and 3, well, 6x times 5 is still greater than 30x. That's not going to work either. So there's just literally a lot of guessing. So I'm ready to try 12x and x. There may be something I can do there. So no matter which way you go, there's this type of guessing. So 15 is that's not going to work either. And if I put 3 here and 5 here, then I'm still not going to work. Oh, okay. Well, this is prime. Unintended. We've just discovered it was prime, but I did not write one down as prime. So this one's prime. It's not the one I wanted to do. The one what I actually have written down isn't 13x, but 17x. So let's do 17x. And let's do 5. So I don't know if this one's prime or not. The other one's prime. I hate doing prime examples, but that was my prime example. That's going to be my prime example. It was an unintended prime example. I had another one I was going to do. I just copied that one down wrong. And it is no surprise mathematically that it is prime. As a matter of fact, a recent theorem was proven that there are far more, in a very real mathematical sense, prime polynomials than polynomials which can be factored. So 5 goes here, and 17 goes here. Well, what's cool about it here is that our constant term is 5. So my only choice there is 1 and 5. So now I'm going to mess around with factors of 12. Well, let's try 6x and 2x. So this is not so bad after all. 6x and 2x gives me 12x squared. 1 times 5 gives me 5. 6x times 1 is 6x. 2x times 5 is 10x. That's close, but not quite there. Let's try some others. So what happens if I try, instead of 6x here and 2x here, we'll just leave those there. We'll move these on the bottom. A lot of these you'll be wanting to do in your head, and my erasing thingy's not being nice to me. So let's try 5 and 1. That's going to work because that's not going to work because 6x times 5 is already 30x. So I need to think of another factorization for 12. Let's try 12 and 1. Let's try that. So this is just the process. So let's try 12x. So x times 12x is 12x squared. 5 times 1 is 5. X times 5 is 5x. 12x times 1 is 12x. Ah, perfect. Nice. Now I have it. 5x plus 12x is 17x, and I'm ready to go. Yeah, that one took a little bit longer. Sometimes they don't. Sometimes you see them right offhand or you get lucky. So the factorization, don't forget, is this. So this factorization is x plus 1 times 12x plus 5. Okay, so let's do another one. Yeah, basically these are, you just have to practice. I mean, it's the guess and check. So 3x squared plus 10x minus 8. Nice, our leading term is prime. That reduces our choices. Now, if only our constant term was prime, we could find it really fast one way or the other. But our constant term isn't prime. But I think we'll be okay. Since our leading coefficient on our leading term is prime, is 3, I'm just going to do 3x and x. So notice this is negative and this is positive. So exactly one of these factors is going to be negative and the other is going to be positive. So we're going to just try maybe minus 2 and 4. Well, that's going to give me minus 6x plus 4x. Well, that's not 10x, so let's try something else. Let's put the 4 here. And the minus 2 there. So 3x times 4 is 12x. X times minus 2 is minus 2x. Ah, that's what we needed. So let's check. 3x times x is 3x squared. 4 times minus 2 is minus 8. And 12x minus 2x is 10x. So our factorization is right there for us just to pull off the table, or the chart, or the whatever you want to call this, the diagram. So it becomes 3x minus 2 times 4 plus x. And my last one, $24, how horrible. X squared plus 41x plus 12. Ugh. Nothing nice about that at all. But you know what we've not been doing? What is the G? Does 41, 24, 41, and 12 share any common factors? They don't. 2 divides 24, but it does not divide 41. 41 is prime. How do I know 41 is prime? Well, there's a theorem that says the square root of 41, which is less than 7, 41 has to be divided by a prime that is less than its square root. The square root of 49, which is greater than 41, is equal to 7. So the square root of 41 is less than 7. So our primes less than 7 are just 2 and 3 and 5. Clearly 41 is not divisible by 2. Clearly 41 is not divisible by 5. Is it divisible by 3? Well, we do the divisibility by 3, check, and we add the digits. We get 5, and 5 is not divisible by 3, so 41 has to be prime. That's how I did that. It's those divisibility checks or test. The only thing I didn't talk about is any number has to be divisible by at least one prime that is less than or equal to its square root. Now, of course, we don't know what the square root of 41 is, but I know that the square root of 49 is 7, so it's got to be a prime less than 7, and those are my primes less than 7. So you don't have to do that, but I did it, and I kind of, when I do things like that, that's going to make it helpful. Knowing that 41 is prime, well, it's not going to make it too much helpful because 41 is our middle term, so it doesn't help at all. 12 and 24 x squared. Oh, we got to do this. So 24x squared, let's try 6. So let's think. 24. I'm not wanting to use my eraser today. So 24. There has to be an x in one of these. So let's look at 24. 24 is equal to 1 times 24, 2 times 12, 3 times 8, 4 times 6. So those are a lot of factors. And 12 is equal to 1 times 12, 2 times 6, and 3 times 4. The only nice thing about this is everything is positive. So I'm going to try the 6 and 4 for the 24x. So that's 6x and 4x. And I want these to add up to 41. So 1 and 12 is not going to work in either slot. What about 6 and 2? Well, that gives me 36x plus 8x. That was close, but it still didn't work because 36x plus 8x is not 41x. But it was close. Well, we could try 2 and 6. Well, that's going to get me 12x plus 24x, and that's not 41x. Let's try, I'm ready to try 1 and 12. And didn't we already try 1 and 12, 3 and 4? I'm ready to try something up here, different. Let's try 2 and 12. So what I'm saying is, so I tried that, so let's try 2 and 12. 2x, 12x. So down here, let's do 3 and 4. Well, 12 times 4 is 46, so that's not a good choice. Let's try 4 and 3. Well, that's 36x, and this is 8x. That's not going to work either because it's even. It's not even, it's odd. So let's use that. Since it's odd, I want one of my factors of 24 to be odd, and the only way I'm going to get that is using 1 and 24. So now you see what it means by the guess and check method. And that's all there, that's the only thing we can do. So I'm going to use my x and 24 x. And down here I'm going to use, I need an odd number. 3, that's not going to work. I'm taking it back. I know I need an odd number somewhere. And notice here I have an odd only 3 and 8 and 1 and 24. So let's do the 3 and 8. So 3x times 8x. And let's do 3 and 4. So that's 9x plus 32x. And I finally get it. Because 32x plus 9x is 41x. So that was a lot of work. So our answer turns out to be, so it's a lot of thinking. Notice that I realized at some point that I kept getting even numbers and I needed an odd number. So that's what made me look at 1 and 12. That didn't work. We actually got rid of that the first time. So I need a factor of 3 and another factor, an odd factor. So at any rate, we succeeded in the factorization. You just got to persist. You say, oh, what happens if that were prime? And that would be a mess, wouldn't it? Because you have to keep track of all of your possibilities. And there's some negative possibilities down here. Minus 1, minus 12. Minus 2, minus 6. Minus 3, minus 4. But since this itself is positive, I don't have to worry about those. But you have to keep track of everything. And then once you know you've exhausted everything, then you could say it's prime. But of course, it's not prime. We actually found its factorization. X plus 3, 3x plus 4. Okay, that's enough of those. Now you see why some students just hate factoring. And any other method I know to factor that is just as guess and checky as what we just did. So now we're just going to do factoring by grouping. Factoring by grouping is a central part of another type of factoring, the AC method. But we're not going to do the AC method. But factoring by grouping is still important to do. So we did a few in our last lecture, no, 2 lectures ago. Let's do a few more now. So we have x squared. So we're going to have 4 terms. X squared plus 3x plus 2x plus 6. So what you do not want to do here is simplify by adding the middle terms. Instead, you want to bring it into 2 groups of 2 and find the GCF of x squared and 3x, and that's just equal to x, and then the GCF of the second group, 2x and 6. So that's equal to 2. So you bring out your GCF of the first here, x, and then plus 2 in your grouping. So x squared divided by x is x. 3x divided by x is plus 3. 2x divided by 2 is x. 6 divided by 2 is 3. So now broken it down, into a grouping of 2. And the greatest common factor of these two terms is my x plus 3 term. So I'm going to pull out my x plus 3 term because it's the only thing that is the same in both of these two factors. So this is factor 1, and this is factor 2. And the only common factor is the factor of x plus 3. So I'm going to pull out my x plus 3. And x times x plus 3 divided by x plus 3 just leaves me an x. And 2 times x plus 3 divided by x plus 3 just leaves me a 2. So I was able to factor this by grouping. So let's do something here. I'm just going to show you this, and I'm only going to do one example. Now suppose I actually were to simplify x squared plus 3x plus 2x plus 6. I would get x squared plus 5x plus 6. And lo and behold, I automatically have the factorization of this polynomial right here by factoring by grouping.